So to solve this equation, we can't factor by grouping. So instead, what we do is first we would create a list of all possible rational zeros. So that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all divided by plus or minus 1. So step 2, then I would graph this, take a look at it, and figure out that indeed negative 3 looks to be like a 0 to this equation. So using negative 3, I'd then use synthetic division and pull out the other factors. So I would do skip a line, draw a line, go down, and I would add this all up. So this would give me negative 3, this would give me negative an 18, 6 and negative 18, there we go. Then negative 2, and then a positive 6 and 0, so this indeed verifies. And what do you have left over? You have this, you have x squared plus 6x minus 2, and you're trying to solve when that's equal to 0. Well, you have to use the quadratic form of this one because we can't factor it. So a is equal to 1 in this case, b is equal to 6, and then c is equal to negative 2. So I would check b squared minus 4ac, the discriminant, and I would get 36 plus 8. So I think I'm getting 44 out of this thing. So then I would realize, okay, so x must be negative b plus or minus the square root, b squared minus 4ac over 2a, just the quadratic formula. So x would have to be negative 6 plus or minus the square root of 44, all my hard work in step number 2 over there, divided by 2. So that looks like negative 6 plus or minus, when I simplify all of this thing, I'm going to get 4 and 11. So that is going to, so let me 2, we're at 11, and then all divided by 2. So when it's all said and done, looks like x is equal to negative 3 plus or minus the square root of 11. So all of my zeros, when I'm all said and done, will be these two and the other one which I found originally, negative 3. So there is my solution.